Hey guys, welcome to my video. This is Saritha here. Are you looking for knowing different ways of doing the same question along with the short method? Then this video is for you. And in my today's topic, I am discussing on binomial theorem, identities involving binomial coefficient. So stay tuned with me till the end of the video, and if you feel the content is useful, please like, share and subscribe to my channel. I also look forward to catch up with you in my next videos. So let's get into the topic. This is another example. 1 plus x whole power n is c0 plus c1x plus c2x square up to cn x raised to n. And we need to find out the value of c0 plus 2 times c1 plus 3 times c2 up to n plus 1 times cn. So the regular method is, let us assume the given series as some s. Here the coefficients are in AP. So regular method is applicable whenever the coefficients are in AP. And we write the same series in the reverse order using the property NCR is equal to NC n minus R. So I will be writing the first term as n plus 1. Instead of Cn, I will write C0. Second term, I will be writing it as n times C1. So in this order, if I'm adding these two terms, these two summations, 2 times S will give us n plus 2 times C0 plus C1 plus C2 up to Cn. And we already know that this summation is going to be n plus 2 times 2 raised to n. So when we divide both sides with 2, we would end up getting n plus 2 times 2 raised to n minus 1. So this is the regular method which can be used in your regular board examinations also. And another method is like when we go with an expansion 1 plus x whole power n. This is c0 plus c1x plus c2x square till cn x raised to n. So in order to keep c0, since it's a constant, if I directly differentiate, it would come as 0 and the c0 term will not be visible here. So in order to keep, let us multiply both sides with x so that every term will change here. And now let us differentiate this. While we differentiate on the right side, we will be getting c0 plus 2 times c1x, 3 times c2x square, n plus 1 times cn x raised to n. Whereas on the left side, I have to use the product rule. Keeping 1 plus x whole power n as it is, differentiating x would be 1 plus, if I'm differentiating 1 plus x whole power n, it is n into 1 plus x whole power n minus 1 into x. Now plug in x is equal to 1 on both sides. That would give the required summation as n plus 2 into 2 raised to n minus 1 on the left side. And on the right side, you will have the required summation like c0 plus 2 times c1 plus 3 times c2 up to n terms. This is by differentiation method. Now let's see if we use a summation method. There is a property for NCR, which is n by r. We can write n minus 1 CR minus 1. So basically the given summation is in the form of r times NCR. R plus 1 times NCR. Instead of r, it is r plus 1. So initially we can split this as R times NCR as one term plus summation of NCR as the other term. So R times NCR, I'll use this property. R gets removed because I'm splitting this as N by R, N minus 1 C R minus 1 plus this is 2 raised to N. And since N has nothing to do with the summation, we can write it outside. And sigma N minus 1 C R minus 1 is 2 raised to N minus 1. So in both the terms, if I'm taking 2 to the power of N minus 1 common, again I'll be getting N plus 2. This is by summation method. And last but not the least, and the final method which we generally like to use, plug in N is equal to 2 and write down the series. So the series will be 2 times 2C0 plus 2 times 2C1 plus 3 times 2C2. So this will be 1 plus 4 plus 3, which is 8. Now plug in N is equal to 2 in the options and check which option is giving you 8. I think it's option A. It satisfies. I hope you liked all the methods. Keep watching my videos. I'll come up with more such interesting ways of doing the questions. Stay tuned. Plus x whole power n is C0 plus C1x, C2x square up to Cn x raised to n. So when we wanted to find out the sum of the series like C0, C1 plus C1, C2, C2, C3 up to Cn minus 1 Cn. Since it seems to be a product of two binomial coefficients, we would be considering here two expansions. One in the form of 1 plus x whole power n, writing it in the form of C0 plus C1x plus C2x square up to Cn x raised to n. Other in the form of x plus 1 whole power n, that is C0 x raised to n, C1 x raised to n minus 1 up to Cn. So when we look at the terms, if C0 is to be multiplied with C1, that seems to be a term with x raised to n minus 1. Basically, this collection of C0, C1 and C1, C2, C2, C3 seems to be a term with x raised to n minus 1. If you look at the other way around, it seems to be x raised to n plus 1. Both the ways you can try the question and both gives you the same answer. So collection of the given series is basically the coefficient of x bar n minus 1 in the product of above two expansions on the right side. So in order to find the value of this, we need to find the coefficient of x bar n minus 1 in the product of left hand side. That is 1 plus x whole power 2n. And we already learned how to find a particular coefficient in an expansion. And that would directly give 2nc n minus 1. And this can be considered as a standard result. When the base difference is going to be 1, we will be getting 2nc n minus 1. When the base difference is going to be r, the standard result is 2nc n minus r. So you can create plenty of questions by taking different values of r. Like if a series which is starting from C0 and then C4, the base difference is going to be 4. So the value of this summation comes out as 2nc4. So the final value of this expansion, this series is 2nc n minus 1. So when we expand it using NCR definition, obviously we'll get the answer as C here. But the short method, what we can go with is Just plug in n as 2. So n as 2 gives us only product of binomial coefficients and sum of only two terms, C0 C1 plus C1 C2. So it is basically 2C0, 2C1, 2C1, 2C2. So let us evaluate this. So 2 plus 2, which is 4. Now plug in ns2 in the options. So when I plug in ns2 in the options, I would be getting the C option, which is satisfied. So this is another example where you can directly try to eliminate the options by substituting in values. So many of the series questions you can use this method to verify. If you know the original method, try to solve it with the original method. In case if you want to verify your answer, you can always plug in values and check. Let's see this question. The sum of the terms of the series 3 times NC0 minus 8 times NC1 plus 13 times NC2 minus 18 times NC3 and so on. In order to find the sum of this, the regular and the normal method is we group the terms with common coefficients. Let's say here we are having 3 as a beginning coefficient. So we can take out 3 common. I will have NC0. And so if I'm taking 3 common here, out of 8, 8 can be splitted into 3 and 5. This can be splitted as 10 and 3. So this way when we take out 3 common, we will have NC1 plus NC2 minus NC3. This is a summation we are going to get. And from the remaining, we have the 5 common, NC1, and we should take minus 5 common. Then 2 times NC2 plus 3 times NC3 and so on. Now the value of the first summation is also 0 because it is a standard result. Even the second summation is also 0. Finally, the total value of the sum should be 0. The answer should be B. Why the second part is 0 here? Let us see that. If we are taking the expansion of 1 minus x whole power n, and write the expansion NC0 minus NC1x plus NC2x square and so on with alternate plus minus signs. Upon differentiating on both sides, we'll be getting minus n 1 minus x to the raised to n minus 1. And here minus NC1 plus 2 times NC2x minus 3 times NC3x square and so on. So when we plug in x as 1 here on both sides, we would get the summation NC1 minus 2 times NC2 plus 3 times NC3. This summation value will be 0. So this is a normal way of segregating the terms with common coefficients, and then we'll try to evaluate this required sum. And let's say what is a short method of it. The short method is we can just plug in n as 2 here. So when you plug in n as 2 here, the summation converts to 3 times 2C0 minus 8 times 2C1 plus 13 times 2C2. So when we plug in these values here, so we will be having 3 here minus 8 times 2 plus 13. Overall, the summation comes out as 0. So many of the questions in binomial series questions, this kind of substitution always works. Now let us go to the options and plug in n as 2. So first option, when we plug in n as 2, it doesn't give you 0. Anyway, the second option is already there. In case if it is a multi-correct question, it is better to check every option. So I'm trying to do that. For option C, if I plug in n as 2 also, it doesn't give us 0 because both of them are positive numbers. And even in the D option, it can't be 0 because n is a proper number here, that is 2. 2 into 2 square will give you 8. So this way, if you check all the options, you'll be able to figure out if it is a multi-correct question also. Directly, when we are able to evaluate it as 0 and that option is visible, in order to check whether the other options also satisfies, we can plug in n as 2. Here is another example. 1 plus